All right. Hi, everyone. My name is Joseph. Okay, I guess I should get to the introduction part later. I'll be talking about the state of user interaction tonight. And my name is Joseph Rex, and I write software for a living. I design sometimes for fun. I experiment with animation libraries, and I have a passion for interaction. Um, so on the quest to understand how to create better user interfaces and create better interaction for users. A lot of us developers find ourselves regularly looking back through history to see how interaction was built, looking through books that explained how technologies like the mouse and touchpads were created. And a lot of all of that, those things we use today come from just understanding how humans interact with computers and how computers understand human intent. So, according to one of the originators or one of the people who came up with the term user interaction, um, there are five dimensions of interaction, which it consists of words, visual representation, space, time, behavior. And when we build user interfaces for people to interact with, there has to be a little piece of all of these five dimensions in them. So the word aspect would see typically a user interface could have something like this that says uploading three files. Because we build these interfaces for human beings, we want them to communicate something to our users and tell a story sometimes, and sometimes just give them something to help them not worry about what happens next. Just keep them in a relaxed state and assure them that there's some progress going on. And speaking of words, there's one typical example I have that I failed to include in my slide. If any of you happens to use iTunes, you'd notice that when you're subscribing to a new podcast, you click the subscribe button and it feels like nothing happens. And um, because the word never changes from subscribe to maybe unsubscribe or showing that you've subscribed. And at that point, there's a failure in interaction. There's like that lack of communication or lack of feedback from that interface. Hopefully, Apple fixes that someday. Um, then another aspect of it is visual representation, where we have little things just express to us what's going on. They might not particularly be serving much of a purpose, but visual interaction just helps the user. Like we have these illustrations that, um, like the word says, they illustrate our intentions in a clear way for our users to be able to relate with. Then we also have spacing. Spacing in user interfaces could range from a variety of things. It could be the space that determines what aspects can be interacted with, and we have these actionable targets on user interfaces where you need to create spaces for between various actionable targets, even if it's just drag actions and other forms of interaction. Another critical part of interaction is time. It could be the duration of events occurring. It could also be events that occur within intervals of time. And whenever we build interactive interfaces, these are things we have to consider. We also have to consider human behavior and how our users adapt to our interface for the things that we work on. So when we translate all of these things into the technical terms that we use in our industry today, in the web industry and perhaps mobile industry and software development in general, take it all into information architecture, illustrations, spaced actionable targets, um, well-timed durations and delays, because we know animations and transitions do not just always make interaction better. Sometimes they could make it worse if you have too much time on durations and if you have too much delays. And we also have adaptive feedback. So since we're speaking about React, um, I want we want to think about how React can help us with these problems or these things that we're trying to solve in the web today. Um, and React plays a good role for us by providing states. Um, and that's not just React. That's the same thing with Vue. That's the same thing with any UI library that helps us to consider states. But the problem with states is, since they've been created, we tend to underuse them. And when we underuse states, it means circumstances happen where we haven't anticipated what's going to happen, or we have unanticipated circumstances, which in turn lead to unexpected bugs. So uh, basically, by having React as a library, we want to be able to consider every possible state for every interaction and every operation that's going on our applications, websites, because those things would help us to, in turn, tackle bugs before they happen. And no one is perfect still. You still might have little bugs to fix. You still might have to run tests to ensure that certain things aren't happening. But I think over the past years, we've geared towards building defensive coding mechanism rather than building um, things that are what's the word, like things that pervert against these things, from things that plan ahead for, there's a word for it I can't think of right now, but rather than building interfaces where we are planning ahead for unexpected things to happen, and providing the right feedback or the right um, handlers for our users ahead of time, we create these interfaces and then build defense mechanisms to tackle bugs that then occur, which in turn feels like we are patching our interfaces with duct tapes. So some commonly ignored states when we build interfaces, especially, would be the states for unfound record and null pointers. In JavaScript, for example, you have cases where you are fetching a record from a database, and there's um, there's multiple levels of an object where um, this dot that, and you have the error, cannot find undefined, or undefined is not a property of, or object A is not a property of undefined. Then we also have empty records where we have nothing returned from a successful response, and then there's no interface that's planned for the users when we get this empty response. We have general errors. It could be a server-side 500 error. It could be something the user did wrong that causes a 400 category error, and it could also be that the user wants to cancel an event that's already been triggered. And we have no interfaces planned for situations like this. So these kind of things are what in turn causes some unexpected UI bugs. And that's because, once again, we aren't planning our interfaces effectively or as good as we should. So a typical React application that's making an HTTP request would go through the steps, import the libraries, create a state for what's being fetched, the data that's being fetched. And when that data becomes available, you set it to the state and then you use it simply. So the first problem with this piece of code is um, first problem with this is if this data comes back and it comes back with nothing, um, I would say I'm partially safeguarded by having the by having an empty object because JavaScript typically would not complain about null pointer for an empty object. It's just going to say it's undefined. So I'm safeguarded for user.name at this point. But by time to fetch user.image.thumbnail, then I'll get an error. You could maybe create some defense mechanisms by using default object parameters on this use state, or do other tricks that might seem interesting. But with all of that coding mechanisms we bring in here, we are only being too defensive and still not planning for our users enough and still not planning the state good enough for our users. So perhaps a better thing to do in such case might be to consider errors. We might consider the errors that would occur, and when errors occur, we show the errors instead. But the problem with this is the error we capture at this point is an error for our server request. So we probably wouldn't be catching this error yet, but at least we consider this error from the server, which is better than the situation we had before without thinking about what comes back from the server, if it's a successful or failed response. So the next thing we tend to think about is the Loudoun State. And this happens halfway through the application when you see that that in-between state while it's loading, you might be getting an undefined display on your web page or an undefined error, whereas you know that this data exists, it's just not available at the point where um, the DOM, the component gets initially mounted to the DOM. Uh, so in order to prevent errors like this, you could create extra safeguards with a Boolean operator like if it's loading, then return loading, which would give us, which would prevent that error for that time and give us this result. I'm sorry. So again, this whole thing we have does not list the problem completely. We just keep going and going, and we have this endless unplanned states, and we keep creating more conditions um, for unexpected events, which feels like we're only writing code to solve bugs rather than to create a solution. So I'll walk us through a sample code that I have, which does what I think and what some other people so far are seeing as perhaps a better alternative to, okay, perhaps a better alternative to, I'm sorry.
No, you're good, man. Take your time.
Yeah, this is taking a while to load.
You're using
And it's
slides.com,
downloaded
right?
from Code Sandbox. So I'm just going to walk through the code while I hope that that loads up. So what we have here is a React code that uses use with user along with use effects. And I'm sorry. Once again. Uh, yeah, my browser seems like it's freezing from this code sandbox page. Yeah.
And it's probably having a hard time trying to load it, embed it into a slide on the website. You can even pull the drawer a little bit so that you get a little bit more code room. So that middle line right there, you can pull that to the side, and there you go, and open up the code space a little bit more for now, so that you can just focus on the code. And then if that does end up loading, we can see the UI. But for now, we can just focus here, and we're good to go.
Okay. Sounds good. All right. So here's the code that I have where we have all this states planned. Um, I'm just gonna go over the code real quick. So we have this use effect where we are saying if the status of the request isn't loading, then we don't need to be in here because we already have properly planned states, and the only state with which we want to be dealing with a side effect is when the user is loading data, and whenever data is being loaded, we could fetch from our API, get some response, and based on that response, we dispatch something and we reject whatever. But um, I'm trying to get, yeah, I think that might be a good idea. Let's see, is this working? Okay. Okay, so also everyone still sees my code sandbox screen. All right. Oh, great. So what I have in here is something that looks like a finite state machine, and I know some of us might be familiar with finite state machines because they've been often discussed. Let's see what's going on. Okay, so some of us have come across finite state machines, and I know a lot of people stay away from finite state machines because of the idea that they might be too complex or rather too complicated to deal with initially. But um, I think this might be a good ease into the concept of finite state machines, and it might even be a sufficient solution in most cases. So what we have happening here is we have this page loading for a specific user, and we have a button that could update the user um, using the same function in the same place. So in order to have that, we have a request renderer function that takes account of every possible state in our application, and we are doing this with no libraries. Uh, so we have all our possible request states. Again, we want to anticipate everything that could possibly happen for a request. So a request could be idle, a request could be loading, a request could come back successful, a request could come back successful but empty, which we have in here. Then a request could fail completely. It could be a server-side error, it could be a client-side error. But however the error might be, we might have one interface to handle it all. The point is building this interactive platform for our users. We are considering that an error might happen, and we might have to beautiful illustration to show for errors. The message you send back might vary, but what matters is that state of error has been planned. So our request renderer shows all our states, and we have for all the states, this could have easily been a switch, but I have this object of functions, And the reason why I have no objective functions is because um, this is because of extra performance reasons where we could have really heavy components being loaded in here. And by like profile, for example, that I load up, user profile that I load up on success might be a very heavy component that I don't want to mount simply by assigning this object. But if I had just thrown in that value of the of profile to the success, then um, I get to execute that whole component too early or too eager, which might cause some performance issues. So the best situation is to hide it all into, or best solution here is to hide it all into functions that eventually get called when we determine the state we're in. So at the bottom here, we have something that might look like a query. For anyone that's familiar with functional programming, querying, we have something that kind of looks like a query, but I wouldn't exactly call it a query function. So when we pass in the status to the request render, it determines what content to be shown based on the current status. And the rest of these two things are just there for information. Um, but status determines what shows in this interface. In turn, it saves us from having multiple if statements, multiple safeguards, because we are already planned for, we planned ahead for all these um, states that are going to happen. So when we get the state, then we execute the function that renders whatever the state has to offer. So going back in here, we probably would never hit an idle state. So idle state just exists again in order to take account that the request might be idle at some point. But when you look back into my initial state for my reducer, my initial state or my initial status is loading. So with the loading state, I probably would never hit that idle state. And why this feels like a finite state machine, of which it's not, is because we have this process, we have all of these states that are finite that we might eat, but we might not necessarily eat them. And what makes this different from a finite state machine is um, there's no enforcement. We are very free to dispatch whatever we want at any time, which would trigger any of the states without restrictions. So the only little restriction we have is this condition here saying if the status is loading, then it should perform a fetch. So for every other thing, we do not need to perform that fetch. So I'm just going to go back into the reducer aspect, assuming not everyone use reducer a lot. So what use reducer is doing for me in here is it takes every dispatch. So it takes every dispatch from the start of the application. It feels like we're dispatching for a load state, which has no payload. And when we dispatch for load, or dispatch for a fetch, when we dispatch for a fetch, it changes our status to loading and it just loads the data. So the next point in that whole process in our reducer is the data comes in and then we dispatch for a resolve, which changes the status to success. It provides us with data to the payload that we provided. And whenever we encounter server-side errors, we send in a reject dispatch. Having this dispatch function means I could have other kind of errors to handle, and I would simply just dispatch the same. I'll simply just dispatch the same thing and provide the error as a payload. This way, my application is a little more predictable, and it knows that my dispatch is always expecting an error for a reject type, I should always pass in an error. And for every case like that, it means I could call this dispatch wherever I want to, not just within my um, server side, my server request. So I do something similar in order to fetch all this data that happened on the beginning. I do that with this button. So our button, by clicking fetch random user, we fetch a totally new user just by calling our dispatch and telling it to fetch. The fetch dispatch would come back into our reducer and change our status into loading, which goes back to our use effects. And I don't know if I have to enlarge my code. Is this visible enough? Okay. So yes, I am. Oh, oh, good. Class. Okay. Okay. Great. So, oh, great. Thanks for that. The link to, I'm also going to share the link to this talk. So, because it has the embedded code sandbox. So, just back to the button, we could click this button and then that dispatches a fetch, which goes back to the reducer and changes our status back to loading again. And that goes back to our use effect, which performs the request because the status is loading. So one thing we have to make sure of is to just list our request status as a dependency for our use effects. And that's what makes the dispatch to trigger our use effect each time that happens. So that's this aspect to thinking about states when building interfaces. And by being aware of states, we can further anticipate every other thing we need on our interface. Um, I love CSS, and one of the reasons why I think CSS is a great language is because CSS as a language has all those interactive elements where the possible states around them are well planned and well anticipated. It's left to you as a designer or developer to create appropriate designs for all the states they provided. Think about a button. When you have a button, you could decide I want to create a design for, or I'll use a link. When you have a link, you could create a design for when the link has been visited, create a design for when the link gets focused, you create a design for the click events or just the click, which is still similar to the focus. And
Hey, Joseph, could you full screen the slides again?
okay, yeah, I'll do that.
Thank you.
So yeah, so just with CSS, you could do all of these things by being aware of the states. And I think one of the biggest takeaways that I want to give from this talk is that we are able to do so much with CSS, as simple as it seems, because CSS makes us aware of all the possible states we can use. So why do we build applications without making ourselves aware of the states that are available to us? So it's if there's a name for this kind of programming, maybe it's state-aware programming or state-aware UI development, because I don't want to call it finite state machine since that's not what it is exactly. So by being aware of state, we can come up with a plan for information architecture. because if you have a team of designers and copywriters, you then have all these different interfaces that you've planned for. Back to that code sandbox, all of those things that I passed into our request renderer could be separate components that are well designed and well thought through. So if you have a design team, they could have created beautiful empty states with good information on them. They could have created beautiful state for each of a beautiful user interface for each of those states that you would encounter, and you would only really think about doing these things when you are aware of those states and you plan those states properly. Um, Also, the same thing applies to illustrations for teams that love illustrations and love to build, those beautiful touches to user interfaces. Then just thinking about this entire thing might also help you consider more interactive feedback and just effects that make your interface more appealing at every possible state. There are other parts of this 5 dimensions that aren't explicitly being solved by state awareness. Um, and those are like the time interval and I think adaptive feedback. There was this other thing when we go back all the way back. So we have the time durations and we have the spaced actionable targets. So these two things, do I have? So space actionable targets, the well time durations, those do not exactly get fixed by considering states, but thinking about states to our application is one way, is solves half of our problems in creating very interactive interfaces and um, good interfaces for our users to interact with. So, and I think that's all for me, and that's all that I wanted to cover in this talk. So thank you, everyone that's available on the talk. I appreciate
Joseph,
you being
thank you
on
so
this.
much for coming out. That was awesome. Phenomenal. Definitely great code examples. I can't wait to dig into the code sandbox. We actually posted the link in the chat for everybody to go check out that sandbox and dig into your code a little bit. I'm just going to, real quick, do you have time if there's any questions coming in from the chat? Let me ask real quick.
Yeah,
I
yeah.
know at one point, I'm pretty sure the one question I did see was from Ryan Harrison. It was about, are you, would you consider using something like X state, or do you try and stay away from those kind of finite state machines?
I think Xstate is a wonderful tool, and I personally would. But the thing about tooling is people get very political about tools and very
Definitely.
opinionated with them. That um, if I had a team and I told everyone that I think Xstate is cool, people would hardly agree with me, and people would think, the fact that you have to write a whole machine for Xstate and then import that. It tends to look messy real fast.
Sure.
And even though it looks messy, it's solving an actual problem. It's doing a great job. But yeah, it's hard to convince someone to use that over just being aware of states in general.
See, I think I agree with that. I think one of the things though is that it's kind of like Redux, right? Like Redux is such a large thing to put into an app, and what happens is when you get early adopters of something like that, they start to really push everything into Redux when realistically Redux is just for complex shared state, right? Instead of it needing to be every piece of state, it should have only been complex shared states that people were pushing into it. But what happens is you get early adopters of it who think, okay, I'm building out a form. Let me just push all of my inputs up to Redux. I think XState fits very similarly where if you're dealing with a very contrived and blown up UI example that really does hit so many cases of state, XState is the perfect tool to fit in there. And I think that otherwise it should be left out and you should definitely try and get kind of through the brushes just using React's internal state tools, which at this point are definitely some of the more powerful tools that I think are in most there's definitely ways to handle states in a lot of frameworks, but I think since the introduction of hooks to React, it's shown a much more powerful toolkit kind of in the React ecosystem to handle even more complex states than you would think in just the library itself.
Yes, I totally agree. I feel the exact same way about Redux, and I
Yeah, I
think
spent like 2 jobs dealing with Redux now. So, I mean, honestly, with where it's at, I'll be completely honest with you, it's gotten so much better. Like the introduction of React Redux hooks for selectors and dispatch absolutely changed how I write Redux. You get rid of map state to props, map dispatch, no more connecting, individual containers. Like, it made writing it so much better. But hey, Joseph, again, thank you so much for coming out. Phenomenal job. Definitely excited to have you around again. I'll definitely be in touch. If you have any links you want to share, definitely join into our Discord. Drop them in the channels so people can catch up to you. Definitely go follow him at Joseph Rex Me on Twitter, correct? Yeah. Anywhere else?
yeah.
Anything else you wanted to shout out for yourself?
Oh yeah, yeah. My website is josephflex.me, josephflex.me, and josephflexme on every other platform.
Awesome. All right. Thanks a lot. Have a good one.
Uh, yeah, thank you.